Hi there, welcome back. Today we're going to look at section 2.8, which is more techniques for finding derivatives. So at the top of your notes today, the paragraph up here says, because the derivative of a function can be interpreted as the instantaneous slope of the line tangent to the graph of a function, right? We already talked about that. So remember, the derivative is the instantaneous slope of the tangent line to a graph. Okay. It's now possible to find the equation of a line tangent to the graph of a function at a given point. Because if you know the slope, which is the derivative, and you know a point, you can write the equation of a line. Okay. So in this lesson, we will find those equations of tangent lines, and we will also manipulate some functions and rewrite them in a way such that we can use the power rule to find the derivatives. So we're also going to be looking at some more polynomial functions to see if we can find derivatives. So today what we're going to be doing is applying the constant times a function rule. We're going to apply the sum and difference rules, and we're going to find the equation of tangent lines given a point, okay, or at a given point. All right, so let's look at some new concepts, new definitions for today. Number one says, if f of x is a differentiable function, c is a real constant, and y equals c times f of x, then the derivative is c times the derivative of f. So again, this is derivative notation, df over dx. This is what you're taking the derivative of. So f prime. This is kind of the way I would think about it. Okay, so if you have a constant times a function, the derivative is the constant times the derivative of that function. All right, number two says if f of x and g of x are differentiable functions and you're adding or subtracting those functions together, then the derivative, again, this makes more sense to me, is the derivative of f plus or minus the derivative of g. We actually started that on the last section when you had two terms or three terms. Okay? But the big thing today is that we still can only find the derivative of terms that are either added or subtracted to one another. We do not yet know how to do something with multiplying and dividing. Okay, that's coming up. But for today, we have to make everything an addition or subtraction problem. So that's kind of the thing with today. Okay? All right, so let's look at some practice problems. Now, when you guys do these, I would say take a look at each term. First, make sure they're all being added or subtracted to one another, which these are, and make sure you have nothing to kind of switch over to the right form, okay? So for this problem, everything is good. This is a polynomial, we can take the derivative of that. This is a constant, so we know the derivative of that is 0. This is ready to take a derivative, and so is this. So all I have to do for number one, part A, is find the derivative. So again, we're going to do each individual. These are sums, so we can use the sum rule, which is just take the derivative of each individual function or each individual part of this function. So the derivative of negative 2x squared, multiply the coefficient times the exponent. So negative 2 times 2 is negative 4. Subtract 1 from the exponent. So 2 minus 1 is 1. 6/5 has a derivative of 0. You could put plus 0, but you don't need to. Okay. Plus, okay, same thing here. Take the coefficient times the exponent. 5 times 1/4 is 5/4. And then subtract 1 from 1/4. 1/4 minus 4/4 is negative 3/4. Plus, and then lastly, we're going to do 6 times 3, which is 18. And subtract 1 from 3, which we get 2. So there's the derivative for part A. All right, now part B, when I look at this, I would want to fix this first, move that x to the top. I would want to fix this square root so it has a rational exponent. So that's what I meant by looking at each term first before you start taking the derivative, and write it so that we're ready to do that at the next step. So on this one, I would write h of x equals, so I'm not finding the derivative yet, okay? I'm just going to rewrite everything. So x to the fourth is okay. 2 over x, I'm going to write as 2x to the negative 1. I'm going to bring that exponent up. X is okay, so plus x. Then we have minus the square root of x. So I'm going to change the square root of x to its rational form, which is x to the 1/2, and then plus 10. Okay, so now that I have everything ready, I don't have to, I can just now do my derivatives. So this is a good method to do just to make sure every term is ready to go, okay? All right, so now we can do our derivative. So the derivative of x to the fourth, remember that's a 1 out front, so 1 times 4 is 4, subtract 1 from 4, so we get 4x cubed. Now this says plus, but we have 2 times negative 1, so that's going to change that to minus 2x. And then remember, when you subtract 1 from negative 1, negative 1 minus 1 is negative 2. Okay. Plus, this is a constant term. The derivative of any constant term is the coefficient, so that's 1 minus. Okay, this coefficient is 1, so 1 times 1/2 is 1/2. And then subtract 1 from 1/2. So 1/2 minus 1 is negative 1/2. And then for 10, that derivative is 0. Okay, so here's your derivative for part B. Okay. All right, now, number 2 says, use algebraic techniques to rewrite each function as a sum or difference, then find the derivative. So when you look at part A, you might say to yourself, well, I don't know how to do that yet because this is a division problem. That's true, but we can divide each term by x to the fourth and then make this into something that we can take the derivative of. So remember, when you divide everything in the numerator with what's in the denominator. So this is 9x to the 6th over x to the 4th plus 5x to the 9th over x to the 4th. Okay. All right, so that gives you, subtracting your exponents, 6 minus 4 will leave you 9x squared in the top. And over here, subtract your exponents, 9 minus 4 leaves you 5x to the 5th in the top. So this is what you're going to take the derivative of. This right here is simplified to this. So now we have that g of x is 9x squared plus 5x to the 5th. Okay, so that's what we're going to take. Sorry, that's what we're going to take the derivative of. All right, so g prime, 9 times 2 is 18. Subtract 1 from 2 for your exponent, so that's 1. And then 5 times 5 is 25. Subtract 1 from that exponent, leaves you 4. So there's your derivative. Okay. All right, so notice we took something that was not differentiable right now the way we know how to do it. We took a division problem, but we were able to simplify it and get to a sum of 2 terms that we can do. So today, that's kind of how you're going to have to work these problems. Now, eventually, we will learn some rules for dividing, so you won't have to go through this if you don't want to. All right, part B is multiplication. Okay, again, we don't know how to find the derivatives of polynomials being multiplied together. So what we want to do is multiply this out, right? We're going to use FOIL. We're going to multiply this out and get individual terms so that we can take the derivative. All right, so first, 2x squared times 3x squared is 6x to the 4th. On the outer sides, we have 2x squared times 3, which is 6x squared. On the inside, we have 4 times 3x squared, that's 12x squared. And then lastly, 4 times 3 is 12. And we can continue to simplify this because these two middle terms can be added together. So 6x squared plus 12x squared is 18x squared plus 12. So there's our simplified polynomial. And now we have individual terms for f of x. So this is still f of x. So now we can find the derivative. Okay, each individual term. That's all we can do right now. So we can't do the derivatives of these and then multiply them. That's not, we don't know how to do that yet. All right, so the derivative of 6x to the fourth, 6 times 4 is 24. Subtract 1 from 4, we get 3. Plus 18 times 2 is 36. Subtract 1 from 2, we get 1. And that's a constant. So the derivative of 12 is 0. So there's your derivative. Okay. All right. Same thing for part C. We're going to distribute. Now you have fractions, so just take your time with this. Use your calculator if you need to. Okay. So we're going to multiply x to the 3/4 times each of these terms. And remember, when you multiply terms, you add the exponents. Okay. So y equals, we're going to multiply x to the 3/4 times negative 4x to the 1/4. Remember the coefficient in front of this term is 1. So we're going to do 1 times negative 4, which is negative 4. And then you add your exponents. 3/4 plus 1/4 is 4/4, which is 1. Okay, 4 over 4 is 1. All right, then we're going to do x to the 3/4 times negative 3x to the 9/4. So we're going to do minus 1 times that negative 3, so that's the negative 3. And then we're going to add 3/4 plus 9/4, which is 12/4. 12 divided by 4 is 3. And then x to the 3/4 times 6 is just 6x to the 3/4. So we took this and distributed it so that we have 3 individual terms. So now you can take the derivative. So the derivative of a linear term is just the coefficient, so that's negative 4. Now here, be careful, you got negative 3 times 3, that's negative 9x. Subtract 1 from 3, you get 2. And then lastly, you're going to do 6 times 3/4. 6 times 3/4 is 18/4, and you can reduce that. 2 goes into both of those, so we can reduce that to 9/2. So this would be 9/2 x. And then we're going to do 3/4 minus 1. That's 3/4 minus 4/4, which is negative 1/4. Okay, so there's your derivative for that. Okay, so again, today is all about taking whatever is given to you and simplifying it so that you have individual terms that you can simplify or take the derivative of one at a time. All right, this one you just got to do a little bit of work. So this is 4x plus 5x to the 1/2 minus 1 over, change that to rational, so x to the 1/2. All right, so that means we have to divide each of these terms by x to the 1/2. So I'm going to rewrite that over here. So I'm going to do individual. So I'm going to do 4x over x to the 1/2 plus 5x to the 1/2 over x to the 1/2 minus 1 over. All right, so we're going to divide each thing in the numerator with this number. So now it's not looking so bad because this is pretty simple and this is pretty simple. This one's not too bad either. All right, so let's divide. All right, remember this is 1 up here, which is 2 over 2, right? 4x to the first is 2 over 2 is 1. So we subtract your exponents. So 1 minus 1/2, if we're subtracting, okay, that's a 1. So 1 minus 1/2 is 1/2. So that term is 4x to the 1/2. Now here, when you subtract, you get 0. You have the same variable in the top and the bottom. They cancel each other out, so we just have 5. And then here, since there's a 1 in the top, all we got to do is bring this to the top by making that exponent negative. You can put the 1 there if you need to. Okay, and that 1 stays there. But remember, when you take any variable in the denominator and move it up, it becomes negative. All right, so now we have our 3 individual terms. Now we can find the derivative. Okay, so 4 times 1/2 is 2. Subtract 1 from 1/2. 1/2 minus 1 is negative 1/2. 5 has a derivative of 0, so we don't need to put that in here. And then we're going to do the power rule here. -1 times -1/2 is +1/2. And then subtract 1 from -1/2. -1/2 minus 2/2 is -3/2. Okay. You know, you guys have a calculator, so if you're struggling with the fractions, just put it in your calculator. But you should get used to always treating that 1 as, like I said, you know, having that same denominator. So when you subtract 1, think of it as 2/2. That makes it a little bit easier as you're working those problems. Okay? All right, so there's some problems where we had to actually manipulate them a little bit to get to the sum and difference, where we could do the derivatives of each individual term. All right, so the rest of this is about writing equations of tangent lines and answering some questions about some real applications, difference between derivatives and the function values, okay? All right, so number 3 says, consider the function f of x equals x cubed plus 2x minus 4. Part A asks you to find the slope of the tangent line for this function when x is -1. Find the slope. Remember, the slope is the same thing as the derivative. So I need to find the derivative and then plug in -1 into the derivative. Okay, slope is always the derivative. So find the derivative of this. Okay, so we're going to bring the 3 out front times 1. So 3 times 1 is 3, subtract 1, that's 3x squared. That's the linear term, so the derivative of 2x is 2. And then the derivative of -4 is 0. So now, to find the slope of the tangent line at x equals -1, I'm going to find the derivative at -1. That's the slope. This is going to give me the slope. Okay, when x is -1. So plug -1 into your function and work that out. So be careful again. -1 squared is +1. -1 times -1 is +1 times 3. That's 3 plus 2, so we get 5. So that is the slope of this function when x is -1. Okay? It's not an ordered pair with that, it's the slope. Okay? If I asked you to find the slope of this function at x equals -7, that's going to give me a totally different answer. It's just the slope right here. Okay? So now part B says find the equation of a tangent line. All right, so you guys have to remember, anytime you're asked to find the equation of a line, you need a point and slope, okay? So you already have the slope, it's 5, but what we don't have is the point. We have the x value of the point, but we don't have the y value of the point. So we need to find y when x is -1, right? So how do I find y when x is -1? Well, now I'm going to plug -1 into here. This is the function. So I want to find just f of 1. That'll give me the y value. So plug 1 into here, 1 cubed plus 2 times 1 minus 4. That gives you 1 cubed is 1, plus 2 times 1 is 2 minus 4. 3 minus 4 is -1. So the point is -1, -1. Okay, x is -1, y is -1. So now I have a point and I have a slope. Okay, so now you can write the equation of the line. So your point is -1, -1, and the slope is 5. Okay. So remember how to write the equation of a line. I use the point slope formula, which is y minus y1 equals m times x minus x1. Some of you use y equals mx plus b to find b and then write it. That's fine. I just like this because I don't have to do two things. Okay, so I usually use this. So I'm going to substitute in x1 and y1, my x and y values here, and the slope here. So I've got y minus y1, which is -1, equals the slope, which is 5, times x minus, and then x1 is -1. So this gives me y plus 1 equals 5 times x plus 1. Minus a minus is plus. And then I have y plus 1 equals 5x plus 5. We're going to distribute that 5 through there. And I'm running out of room, but we're going to take this positive 1 and subtract it over here. So that's going to make that 5 minus 1, which is 4. So we end up with y equals 5x plus 4. So there's the equation of the line that's tangent to the equation given to us when x is negative 1. Okay? So just so we can kind of make sure, I'm just going to, real quick, let's see what this looks like. So x cubed plus 2x minus 4. You don't have to do this. I just want you to see it. All right, so there's the graph. Okay. All right. And we were looking at where x is negative 1. So down here. So the tangent line right here would be a line that kind of goes like this. Okay, right there. So what we just found is the equation of that line that touches this graph right here at negative 1. When x is negative 1, here we are. So the tangent line has a slope of 5, and the equation of that tangent line is right here, 5x plus 4. Okay? All right, so that's what we just found. So again, if they gave me a different x value, let's say x was 3 or 2, then that would be this point, and I'd have a totally different slope, totally different line. Okay? So there's tons of things they can ask you on a function. This problem happened to just ask you about negative 1. All right, so again, let me go through this real quick. So when you're asked to find the slope at a point, you're going to plug in the point into the derivative. The derivative is the slope. That's how you find the slope of a tangent line. When you're asked to find the equation of the tangent line, you not only need the slope, which we found above, but we also need an ordered pair. Okay, and so they gave you the x value of the ordered pair, but they didn't give you y. So we found y by plugging in the x value into the actual function, not the derivative, but the function. And then once you have a point and a slope, you can find the equation of any line. Okay? All right, let's look at number 4. This says a town's population t years from now can be estimated from this formula. P of t equals 9,850 plus 550t minus 144 square root of t. So they're giving you the formula. Find the population after 9 years. All right, so this is the formula for the town's population. So if we want to find the population after 9 years, we're just going to plug 9 into the formula. So 9850 plus 550 times 9 minus 144 square root of 9. Okay, we're just going to put that in the calculator. So 9850 plus 550 times 9 minus 144, I'm just going to say times 3 instead of putting in the square root of 9. So 14,368. Okay, so that would be the population in 9 years. All right, now part B says find the rate at which the town is growing after 9 years. The rate. So the rate would be people per year, right? That's what we're looking at. How many people per year? So the rate is another word for the derivative, right? It didn't say the average rate, it just says the rate. So this is instantaneous rate in 9 years. So that is the derivative. So we would have to find the derivative of the function. Okay, well that's a constant. So derivative of that is 0. This is the linear term. So the derivative of 550t is just 550. And then this is 144t to the 1/2, right? Square root of t is the same thing as t to the 1/2. So what is the derivative of this term? So we would do 144 times 1/2, which is 72. Subtract 1 from 1/2. 1/2 minus 1 is negative 1/2. Okay. All right, so now I'm going to find the rate in 9 years. So I'm going to find the derivative. The rate is the derivative. Okay. Now, you can put this in your calculator, but this is good practice to remember. T to the negative 1/2 is the same thing as 1 over t to the 1/2, right? We move it back down, it becomes positive, which is the same thing as the square root of t in the bottom. So that might be easier to do it that way. You don't have to. You can just stick that in your calculator. But 72t to the negative 1/2 is the same thing as that. Okay, again, t to the negative 1/2 is the same thing. If I move it back to the bottom, the exponent will become positive. And then anything raised to the 1/2 power is a square root. So this is a little bit easier because I know the square root of 9 is 3, and then I'm just dividing 72 by 3, right? So however you want to do it is fine. So 72 over the square root of 9, that's 550 minus 72 divided by 3, right? So 72 divided by 3 is 24. So we get 550 minus 24, which is 526. Now that's a rate. So this is people per year. Okay, that's a rate. Derivatives are rates. So we were doing how many people per year, right? So in 9 years, the rate of increase is 526 people per year. In 10 years, it's going to be different. Okay, this is just at 9 years. Okay. All right, let's try another one. Okay, number 5 says, when a factory operates from 6 a.m. to 6 p.m., its total fuel consumption varies according to this formula. 0.9 t squared minus 0.2 t to the 1/2 plus 11, where t is the time in hours past 6 a.m. That's important. And f of t is the number of barrels of fuel oil. Okay, so barrels over hours. How many barrels per hour would be a rate? Okay, barrels per hour. So part A says, how much fuel is consumed by 8 a.m.? Okay, how much fuel is consumed? This is how much fuel is consumed. Then ask me for a rate, just how much fuel. So I'm going to plug in 8 into here, or am I going to plug in 2? Okay, so remember, T is the time in hours past 6 a.m. So 6 a.m. is like 0 time. Okay, that's when the time is 0. So at 8 a.m., that means the time would be 2. That's 2 hours past 6 a.m. So we're going to find f of 2. So 0.9 times 2 squared minus 0.2 times 2 to the 1/2 plus 11. Again, plug it right into your calculator. Okay, don't panic about these numbers. You got a calculator. So 0.9 times, I'm just going to say 4, minus 0.2 times 2 to the 1/2. That's the square root of 2, right? But you could put it in like that, doesn't matter. However you want to do it. Square root of 2 plus 11. Okay, so we end up with 14.317. It says round your answer to 2 places. So that is 14.32. And that's barrels. Right? All right. So that's how many barrels it took for 2 hours of this plant, this factory to be open. All right, now part B says, what is the rate of fuel consumption at 9 a.m.? Well, at 9 a.m., the time is 3 hours past 6, right? So we're going to use T as 3. But this time, where are we going to plug 3? We want the rate, which is a derivative. Okay, that's the slope. So we're going to find the derivative first, and then plug 3 into that. Okay, and that would be a rate, barrels per hour. So let's find the derivative. Okay, so 0.9 times 2, that's 1.8. subtract 1 from that, so that's just t, so 1.8t. Okay, we're going to do 0.2 times 1/2, which is 0.5. So 0.2 times 1/2 is 0.1. 0.1 t to the, and then we're going to subtract 1 from 1/2. So 1/2 minus 1 is negative 1/2. And then the derivative of 11 is 0. All right, so we've got 1.8t minus 0.1t to the negative 1/2. Again, that is the same thing as 1.8t minus 0.1 over the square root of t. You could do it either way. You've got a calculator, so it doesn't matter. So we are going to let t equal 3. So now we want to find the rate at 9 a.m., which is 3 hours past 6. Plug it into here. So 1.8 times 3 minus 0.1 divided by the square root of 3. I'm going to plug it in there. You can do it here. Doesn't matter. Okay. Put that in your calculator. 1.8. I'm going to actually do this separate so you can kind of see. So 1.8 times 3 is 5.4. And then minus, let's go ahead and just do this separately. So 0.1. Sometimes it's easier to do things separately so that you make sure that you're not losing parentheses or anything like that. So 0.1 divided by the square root of 3 is 0.0577. I'll leave it there. And so I'm going to do these two numbers. So I'm going to just do 5.4 minus, and then remember on your calculators you can just copy and paste. You don't have to keep typing that over. So 5.5 minus that is 5.34, round in two places again. So 5.34, this would be barrels per hour. Okay, that's a rate. It's not barrels, it's a rate. Okay. All right. Now the last part of this says what is the average rate? So that's a slope formula. Okay, that's the y2 minus y1 over x2 minus x1. Average rate means we have two values going on. And it wants to know the average rate of fuel from 6 a.m. to 2 p.m. All right, well remember at 6 a.m. t is 0, right? That's when we started. At 2 p.m. what would t be? Okay, that's from 6 a.m. to 2 p.m. From 6 to 12 is 6 hours, and another 2, so that would be 8. Okay, now what is the average rate of fuel consumption? So we're going to plug these numbers into here, okay, the rate. Okay. Now, I take that back. We want the average rate, so we need x and y. Okay. So we're actually going to plug these into the function, this function, and then find the slope. So then we're going to do the y2 minus y1. Okay. All right. So we're only going to use a derivative at a specific point. Right. That's instantaneous. This was average. So for average, I need the ordered pairs. So I need to know 0 what and 8 what. I need to know those ordered pairs, and then I can plug them in here. So you get your y values, or in this case, the fuel number from the function. So we're going to plug 0 in here, which is easy. If you plug 0 in here, this term will be 0, and this term will be 0. So f of 0 would be 11. So all I really have to do is plug 8 in here to get what happens at 2 p.m. So we're going to plug 8 in there. Okay. So I'm going to write here, we find f of 0, which is that. And now we're going to find f of 8. Okay. So, oops, sorry. So in case you go back. So how did I get 11? I found f of 0. And I'm going to now find f of 8. So I'm going to put 8 in there. So f of 8, 0.98 squared minus 0.28 to the 1/2 plus 11. Okay. So that's going to give me this number. So we're plugging this into the original function. All right, so I'm going to do that in my calculator. So 0.9 times 8 squared is 64 minus 0.2 times the square root of 8 plus 11. Okay, so just so you can see what I did. So I did 0.9 times 8 squared. 8 squared is 64. You can just put in 8 squared, that's fine. And then minus 0.2 times the square root of 8. You could put in 8 to the 1/2 plus 11. So that'll give me the value at 8, 68.03. Okay. All right. And again, you guys okay with finding f of 0? For f of 0, I'll put it here. We did this times 0 squared minus this times 0 to the 1/2 plus 11. So these two terms were both 0. 0 times anything is 0. So that's where the 11 came from. Okay? All right, so now we can find the average rate. We're going to take y2 minus y1 over x2 minus x1. So we got 68.03 minus 11 over 8 minus 0. So that's going to give us the rate. So 68.03 minus 11 is 57.03 over 8. And then divide that by 8. So we end up with 7.12. And again, it's a rate, barrels per hour. That's the average rate of fuel consumed between 6 a.m. and 2 p.m. Okay. All right, so average, I need both x and y out of the function, or in this case, t and f of t. Okay. And then use your slope formula to find the average. On the first two parts of number 5, it was instantaneous rate. At just one time, that's a derivative. Okay, so that's the difference between those. So be careful with the words when you do your homework. All right. So hopefully that'll get you through the homework for today. So work on that. Let me know if you have any questions. And if not, I'll see you back here for the next section.